Hello friends, today I will discuss the topic gamma and beta functions. So first I will discuss gamma function, and here I will discuss some preliminary ideas and then some derivation, and after that I will discuss some problems on gamma function, and after that I will go for beta function. So first gamma function basically defines through the integral 0 to infinity e to the power minus x to the power n minus 1, and if x to the power n minus 1 is there, then you can write it as gamma n. And obviously, you can write this form if the integral converges, and usually for n greater than 0, you can write this in the form of gamma n. So the first property here we will discuss is gamma n plus 1 equal to n gamma n, and you can easily prove that. So for that we will first need to recall that integration u v dx you can write as u integration v dx minus integration du dx into integration v dx. So this is called integration by parts, and we will use that in our proof. So gamma n plus 1, from this definition you can see gamma n plus 1 you can write 0 to infinity. So put n plus 1 here, so you can get e to the power minus x to the power n dx, and if you use that formula, then you can get, so you will differentiate this x power n, ultimately you will get e power minus x. So integration this one x power n, so 0 to infinity minus integration 0 to infinity minus e power minus x, so integrating e to the power minus x, and then differentiating this, we will get n x to the power n minus 1 dx. Now if you put infinite, then e to the power minus x leads to 0, and again for 0 x to the power n goes to 0. So basically this term will be 0 due to these two terms. Ultimately you will get 0 to infinity. This term ultimately equals to 0. So this is 0 to infinity e power minus x, n will go outside, x power n minus 1 dx, and this is gamma n. So the proof is complete. Now the next proof, so let me clear the board first. So for this we can use the previous one. See, so gamma n equal to, using that formula we can get, if you put n equal to n minus 1, you can get, so put n equal to n minus 1 here, so you will get n minus 1 gamma n minus 1. Again, so n minus 1 into, again using the same argument here, you can get n minus 2 gamma n minus 2, and like this you will get n minus 1 into n minus 2 up to 3 into 2 into gamma 1, and you can easily check that gamma 1 equal to 1. So gamma 1 equal to 1, you will easily check that. So put n equal to 1 here, you can get gamma 1 equal to 0 to infinity e to the power minus x dx, and this integration value is 1. So this is n minus 2, sorry, n minus 1 into n minus 2 up to 3 to 1. This is n minus 1 factorial. So this proof is also completed. Okay, so now we move to the result, that is gamma p into gamma 1 minus p equal to pi cosec p pi. So we will use this result often, and for this one, let's see, gamma 1 by 3 into gamma 2 by 3, you can use this above result as gamma 1 by 3, and you can write 2 by 3 equal to this. Using the above result, you can easily achieve that this is equal to 2 pi by 3. Again, see, if you put p equal to half here, then you can get, using that result, you can get gamma half into gamma half equal to pi cosec pi by 2, and this is equal to pi, so gamma square half equal to pi, so gamma half equal to root pi. This is the result. If you want to put p equal to 1 by 4 here, then you can get gamma 1 by 4 into gamma 3 by 4 equal to pi cosec pi by 4. So like this you can compute these values. Next we move to a result which is, as you can see, 0 to infinity e power minus ax x power n minus 1 dx equal to gamma n by e to the power n. So now the basic form of gamma integral is 0 to infinity e power minus x power n minus 1 dx. This is our gamma n. So actually what we will do, we will try to form this e power minus x. So the idea is put 1.2, we are solving now, put ax equal to z. So if x equal to 0, then z equal to 0. If x equal to infinity, then z equal to infinity. So this integral becomes 0 to infinity e power minus z. X is your z by a, so z by a or n minus 1, and dx. So here you can get dx equal to dz by a, so 1 by a dz, and as you can see, you can just write it down, a power n integration 0 to infinity e to the power minus z, z power n minus 1 dz. And this is same gamma integral, and if it's x or z, it doesn't matter because this is actually the dummy variable. So 1 by a power n, this is gamma n, and result 1.2 we have completed. Now we will move for 1 by 3. This kind of integration can be easily solved by using gamma function. So 0 to infinity e power minus x power 4 dx. Now here the idea is to achieve e power minus x or e power minus z in terms of gamma variable, whatever you can just say. So we will put x to the power 4 equal to z. Now the shortest idea is write down x equal to z power 1 by 4. So dx equal to 1 by 4, z power 1 by 4 minus 1 d. Now x and z 0 to infinity, sorry, so 0 to 0, and if x equal to then z is also infinity. So limit will be 0 to infinity e power minus z, and dx will be, we will put this value 1 by 4, z power 1 by 4 minus 1 digit, and 1 by 4, this is gamma 1 by 4. And gamma 1 by 4, it just keep it like this. Next, we will discuss the problem number 1.4. Here, this is minus infinity to infinity e power minus 1 by 2 x square dx. Here, for gamma function 0 to infinity, so this is an even function, so you can write this 2 into 0 to infinity e power minus half x square dx. Now, just use x square by 2 equal to z. The idea is e power minus z or e power minus x. We are just trying to use the gamma function form. So x square by 2 equal to z. So what will be our x? X equal to root 2 into root z. So dx will be root 2 into half z, half minus 1 dz. Now 2 integration 0 to infinity. As you can see, the limit doesn't changes. So for x and z, it will be the same, e to the power minus z, and dx value will be root 2 by 2 z half minus 1 dz. these two will get cancelled, so root 2 will be on the outside, and 0 to infinity e power minus z, z power half minus 1 dz. And this is a gamma function form, so root 2 into gamma half, and we already know what is the value of gamma half. Gamma half is root pi, so root 2 pi. Problem number 1.4 is completed. Now we will go for 1.5. So this is gamma 2k plus 1 by 2 equal to, we need to prove this. Now we have already proved gamma n plus 1 equal to n gamma n, and let's see, this is equal to, you can write it as plus 1. If it's plus 1, then 2k minus 1 by 2. Just you can adjust this like 2k plus 1 by 2. This you can write 2k minus 1 by 2 gamma 2k minus 1 by 2. And like this you can write 2k minus 1 by 2 into 2k minus 3 by 2 into, like this you can go up to, see, 2k minus 1, 3, then 2k minus 5 by 2, and like this you will go to 5 by 2 into 3 by 2 into 1 by 2 gamma half, and this is root pi, and ultimately we will get that result. And this type of integral we have already discussed. So here you just put x square equal to z, you can easily solve that one. This integral is also a generalization of that, so we will just solve that one. So x to the power n e to the power minus x to the power n dx, and here we will put x to the power n equal to z, so x equal to z power 1 by n, dx equal to 1 by n z power 1 by n minus 1 dz. And the limit will be for z also 0 to infinity, so 0 to infinity, and what will be x power n to z power n by n. From here you can get x power n equal to z power n by n into e power minus z into 1 by n. Now dx is 1 by n into z power 1 by n minus 1 dz, and you will get 1 by n 0 to infinity z power n plus 1 by n minus 1 into e power minus z dz, and this is a gamma function, and this is will be 1 by n gamma n plus 1 by n. And this is similar to the second one. This problem can be easily solved by using the previous argument. Now we will discuss beta function. Beta function has mainly three types of forms. First one is 0 to 1 form, and second one is 0 to infinity form, and third one is 0 to pi by 2 form. So this is trigonometrical form, as you can see. And using form 1, we can easily achieve form 2 or form 3. Let's see how. So first I will show how to achieve form 2. Here, as you can see, the main idea is the limit. Here x ranges from 0 to 1, and here x ranges from 0 to infinity. Here, as you can see, that if you make the transformation z equal to x by 1 minus x, because when x equal to 0, then z is also 0. But when x equal to 1, then z is infinity. This is the main idea why we are using that type of transformation. And from here, we can see that over here we will write x equal to, and not x, 1 by z equal to 1 minus x by x. So 1 by x equal to 1 by z plus 1, and we can get x equal to z by 1 plus z. And also what we need, we got x, we have to compute 1 minus x. So 1 minus x equal to 1 minus z by 1 plus z, and you will get 1 by 1 plus z. And what about dx? You can get dx equal to 1 plus z whole square and 1 plus z minus z. That means into dz. That means you will get 1 by 1 plus z whole square into dz. Now let's see beta m equal to 0 to infinite. So x power m minus 1 is there. So here x equal to z by 1 plus z. So z power m minus 1 by 1 plus z power m minus 1 into 1 minus x. 1 minus x means 1 by 1 plus z, and this power n minus 1. So power plus n minus 1 into this one 1 by 1 plus z whole square dz. And after a slight calculation, we will get 0 to infinity z power n minus 1 dz by 1 plus z power n plus n. And this is from form 1 to form 2. We need to use that transformation. Now, form 1 to form 2. Here, as you can see, this is sine and cos. So x equal to sine square theta if we put, then 1 minus x equal to cos square theta, and dx equal to 2 sine theta cos theta d theta. And you can see from here you can get beta m equal to, now if x equal to 0, then also theta equal to 0, and if x equal to 1, then theta equal to pi by 2. And here you will get sine to the power 2m minus 2 theta cos to the power 2m minus 2 theta into dx, so 2 sine theta cos theta d theta, and you will ultimately achieve form number 3. Well, so next there is a relation between beta and gamma function, and this is an important relation. Beta mn equal to gamma m into gamma n by gamma n plus n, and we will use this relation very frequently. And if time permits, then we can also see how we can prove this relation. And I think we will discuss this at the end of the chapter. So let's discuss the problem first. Okay. So here we need to find the value of j, and as you can see, this is first type. So just recall the first type of beta integral, 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx. This is our beta mn. So here j equal to 1 by pi 0 to 1 t power minus 1 minus t power 3 by 2 dt. So comparing with this one, we can get m minus 1 equal to minus 1 and n minus 1 equal to 3 by 2. From here we can get m equal to half, n equal to 5 by 2, and we will find the value j 1 by pi beta half 5 by 2. Now the relation between beta and gamma is beta mn equal to gamma m into gamma n by gamma m plus n. And as you can see, this is 1 by pi, so gamma half into gamma 5 by 2 by gamma half plus 5 by 2, that means 3. And now we need to compute this value. So gamma half we already know, this is root 5, so 1 by pi will be there, root 5, Gamma 3 we already computed. If this is integer, then gamma m equal to factorial m minus 1. That means this is 2 factorial and gamma 5 by 2. Now we need to clear the board. J equal to 1 by pi into root pi by 2 factorial means 2 and gamma 5 by 2. Now we will use that formula, gamma m equal to m minus 1 gamma m minus 1. So gamma 5 by 2 equal to, that means gamma 5 by 2, you can write this gamma, that means 3 by 2, gamma 3 by 2. Again this 3 by 2 you can write 3 by 2 into half into gamma half, and gamma half is root pi, so 3 by 2 into half into root pi. And ultimately you will get 3 by 2 into half into root pi, and pi, this will get cancelled. 3 by 8. The value of j is 3 by 8. Next, this problem, I think this is from first form to second form. We have already discussed this. So we have just going for problem number 1.10. Here, okay, with this form. We already know the form 3 is 0 to pi by 2, 2 into 0 to pi by 2, sine 2m minus 1 x cos 2n minus 1 x dx equal to beta mn. Now this is equal, so you want to, if you want to calculate that one, then you put 2n minus 1 equal to p and 2n minus 1 equal to q. That means m equal to p plus 1 by 2, n equal to q plus 1 by 2, and ultimately you will get 2 integration 0 to pi by 2 sine px cos qx dx equal to beta p plus 1 by 2 q plus 1 by 2, and you will get this result by dividing 2. Next we will solve some problems on beta integral. Here you can see the range is 0 to 1 and this is some kind of, so form 1 I just wrote it down once more, x power n minus 1, 1 minus x power n minus 1 dx, and here as you can see we will put x to the power 7 for first problem, x to the power 7 equal to u or z, as you can see. So x equal to u to the power 1 by 7 and dx equal to 1 by 7 u to the power 1 by 7 minus 1 du. Now from that part we can get, so limit will be for x equal to 0 u is 0 and for x equal to 1 u is also 1. So limit will be 0 to 1 x cube, so u power 3 by 7 from that part, and 1 minus x power 7 is u, so 1 minus u, it's okay, whole square is also there, no problem, and dx is 1 by 7 u 1 by 7 minus 1 t. Now we need to just simplify that one, so 1 by 7 integration 0 to 1 u power 4 by 7 minus 1 1 minus u power, so n minus 1, you can write 3 minus 1 du, and using that form you can write 1 by 7 beta 4 by 7. Now you can again simplify that one, so you can write it, this is gamma 4 by 7 into gamma 3 by gamma 4 by 7 plus 3. Now let's clear the board first. (1 by 7) and gamma 3 is factorial 2, so 2 by 7 into gamma 4 by 7 by gamma. That means you can write it as 4 by 7 plus 2 plus 1, because we will use the formula gamma n plus 1 equal to n gamma n. Therefore 18 by 7 plus 1, and you can write it 18 by 7 gamma 18 by 7. And I don't know whether what will happen. So let's see. 18 by 7 you can write 11 by 7 plus 1, and that means you can write it as, instead of 18 by 7 you can write 2 by 7 comma 4 by 7, 18 by 7 11 by 7, and again 11 by 7 you can write 4 by 7 plus 1, so 4 by 7 into comma 4 by 7, and this part will get cancelled, and 1 7 will get cancelled, 2 and 4, so 49 by 18 into 22, and whatever you will get, this will be the result. Next part is that one, and this is similar kind of problem. Here you just put x power 4 equal to z and proceed similar to that one. Next is this kind of integral. These are all basically type 3. That means beta mn equal to 2 0 to pi by 2 sine 2m minus 1x cos 2n minus 1 x dx. Now for the first one, you can see, just compare these two and you will get 2n minus 1 equal to 0, actually 0 to pi by 2 sine 5x dx. Now if you put 2n minus 1 equal to 0, that means n equal to half, and 2m minus 1 equal to 5, that means n equal to 3. N equal to 3. Then you just write beta 3 half equal to 2 integration 0 to pi by 2. Just put these two values in that equation, you will get 0 to pi by 2 sine 5x dx. And you just have to compute this. So beta 3 half, it means gamma 3 gamma half by gamma 3 plus half, and proceed accordingly. So you can get the result. And similarly, if you have a cos function, then obviously sine part 0, that means m equal to half, and n, so 2n minus 1 equal to 7 for that one, n equal to 4. And you can easily solve all these kind of problems. And now the integral is sine power 5 cos square x, and this type of integral can also be solved using type 3. So 2n minus 1 equal to 5 and 2n minus 1 equal to 2, and you will get m equal to 3, n equal to 3 by 2. Ultimately you can get beta 3 by 2 equal to 2 integration 0 to pi by 2 sine power 5x cos square x dx. Now you need to just calculate this. So this is equal to 1 by 2 will be there, and 1 by 2 beta 3 by 2 equal to, you can just write half gamma 3 gamma 3 by 2 by gamma 3 plus 3 by 2. And like this you can easily find the value. So gamma 3 by 2 is there, gamma 3 is there, gamma 3 is 2 factorial, so this is 2 and these 2 will get cancelled. Ultimately you have gamma 3 by 2 and the denominator will be gamma 1 plus 3 by 2 plus 2, that means 7 by 2, and you will get gamma 3 by 2. We are just not computing this numerator, you can see shortly why. So 7 by 2 into 5 by 2 into 3 by 2 gamma 3 by 2, and these two will get cancelled and you will get the result. Similarly, this part is also similar to the previous one. Now root tan x, you can just write it down, 5 by 2. Root tan x means sine power half x into by root cos x, so cos power minus half x dx. And you can just solve 2m minus 1 equal to half and 2n minus 1 equal to minus half, and you will get the result. For 1.14, the problem is, okay, x power m minus 1 by this equal to some kind of beta. Okay, this is the form 2. Just recall the form 2 is 0 to infinity x power m minus 1 by 1 plus x power m plus a dx. Now the main problem is here a plus bx is there, but the form is 1 plus x. This is our beta m, and here we need to make a transformation. Here let's see, so either transformation or you can just take the common, and if you take a common from here, then you will get x power m minus 1 and a power m plus n into 1 plus b by a into x power m plus n dx. Now simple, b by a or bx by a equal to z if you put, so dx equal to a by b dz, and the limit will be 0 to infinity, so 0 to infinity, and x means x equal to a by b z, so a power m minus 1 by b power m minus 1 into a power m plus n, and z power m minus 1 by 1 plus z m plus n, and about dx it's a by b dz. And after some calculation you can get a power m will get cancelled, so this will a power m and this a power m will get cancelled, and b power, so ultimately you will get a power n b power m 0 to infinity z power m minus 1 by 1 plus z m plus n dz, and this is our beta form, as you can see from there. This is beta m, so hence the proof. Okay, next we will move that to the problem 1.15. Here 0 to 1 is the limit, and here as you can see this is some kind of type 2 form. So but the problem is the limit is from 0 to 1, and here actually for that reason we will use the same transformation. This is z equal to x by 1 minus x. Here as you can see when x, so that integral converts to, so for x equal to 0 then z equal to 0, and x equal to 1 z equal to infinity. And here okay, we need to calculate something. Let's see. Here what about x? So 1 by z equal to 1 minus x by x. This is 1 by x minus 1. Z equal to, so x equal to saved by 1 plus z dx equal to 1 plus z whole square, and after that you will get 1 and dz. And here what about 1 minus x here? 1 minus x will be 1 by 1 plus z. I hope yep, 1 by 1 plus z, and this transforms to x power n minus 1 means z power n minus 1 and by 1 plus z power n minus 1. And what about 1 minus x? So 1 minus x will be 1 by 1 plus z power n minus 1 into that part, and that part will be, what about a plus bx? Let's see from here, a plus b z by 1 plus z, and ultimately we will get a plus b into z by 1 plus z, and this is in the denominator, 1 plus z power n plus n by a plus b into z, and now dx. What about dx? Okay, dx is dz by 1 plus z whole square, and 1 plus z, this term will get cancelled as you can see, and ultimately we will get 0 to infinity z power n minus 1 by a plus b into z. Now this is similar to the problem we have just solved before, that means 1.14, and I hope we can easily solve that integral. Again, if we can give a hint here, that power will be n plus n. Power will be n plus n, and just take a common and then put a plus b by az equal to some u, and proceed similarly just. Okay, and some problems I will discuss. So for the first problem, as we have already discussed, that we need to put x to the power c equal to z, so that we can achieve the form 1 of beta integral, and this is can use x square. Okay, if we do x square equal to, or x equal to sine theta, then we can get, I hope, let's see, so 0, and if x equal to 1, then we will get y by 2, and sine to the power n theta, and this is 1 minus x square, that means cos square, so cos power minus half theta into sine theta, so n plus 1 d theta, and dx is there, so dx equal to cos theta d theta into cos theta d theta. Now this is actually form 3, and easily solve the problem. And this is looks like form 2. So form 2 actually we will use x square equal to z, and I think this is sufficient to solve the problem. This is also form 2, and you can put k1x by k2 equal to z and solve accordingly. And for this one, okay, let's this is an even function, so first of all 0 to infinity dt by 1 plus t square by k power k plus 1, and this is form 2, so I think you know what to do. So t square by k equal to z, if you prove that, then we will have your result. this one, okay, this is also even function. So 2 integration 0 to n minus 1, 1 minus x square by n minus 1 power n minus 4 by 2. Now if you put x square by n minus 1 equal to z, then what will happen? So if x equal to 0, then z equal to 0. 2 integration 0, right? This is I equal to x. Now 0 to, okay, if x is n minus 1, so z equal to 1, as you can see, and this is 1 minus z and power n minus 4 by 2 into, okay, there is a dx. So from here you need to find x equal to root n minus 1 into z power half, so dz, and you can use that. This is actually form 1, and you can easily solve that one. Now we will solve the problem related to normal distribution, and here we will use gamma integral. So let's see. Here the PDF of normal distribution is given by fx, where the ranges of x is minus infinity to infinity. So we need to show that minus infinity to infinity fx dx equal to 1. And here, as you can see, there are two parameters, mu and sigma, and the result is independent of mu and sigma. So you can take any value of mu and sigma so that the result is true. So first we will solve that one. So we need to show minus infinity to infinity fx dx equal to 1. So let's see. So 1 by root 2 pi sigma minus infinity to infinity e to the power minus 1 upon 2 sigma square x minus mu whole square dx. Now let's put x minus mu by sigma equal to z, and we will get dx equal to sigma dz, and the limit will be, so when x equal to minus infinity, then z is also minus infinity, and for x equal to infinity, z equal to infinity. So let's denote it by I equal to 1 by root 2 by sigma minus infinity to infinity e to the power 1 by, minus z square by 2, and dx is sigma dz. So sigma will get cancelled, and again this is an even function, so you can write 2 by root 2 by 0 to infinity e to the power minus z square by 2 dz. So this is a gamma function, and we will try to solve that one. So for that we have to substitute z square by 2 equal to u, so z equal to root 2 e to the power half, and dz equal to root 2 by 2 u power half minus 1 du, and the limit will be minus infinity to infinity. So 2 by root 2 by integration 0 to infinity, and so there will be no changes of limit by using that transformation, and e power minus u, and the value of dz will be root 2 by 2 u power half minus 1 du, and this root 2 by 2 and 2 by root 2 will get cancelled, so we will get 1 by root pi integration 0 to infinity e power minus u power half minus 1 du, and this is our gamma half, and gamma half is root pi, so ultimately we will get this is equal to 1, and that's the proof. A small property I will discuss is that beta mn equal to beta nn, that is beta function is symmetric for m and n, and it can be easily shown that. So form 3 will start with form 3, and form 3 says that beta mn equal to 2 integration 0 to pi by 2 sine power 2m minus 1 theta cos power 2m minus 1 theta d theta, or sometimes instead of theta you can write x also, no problem. And here you can write this as 0 to pi by 2 and sine 2 minus 1 pi by 2 minus theta cos 2n minus 1 theta, so here pi by 2 minus theta d theta, and you can use that result and ultimately you will get So 0 to pi by 2 sine to the power 2n minus 1 theta cos to the power 2m minus 1 theta d theta, and this is beta in. So the result is trivial. And lastly, we will prove the relation between beta and gamma. So this is actually a complicated proof, and I will try to present it as simple as possible. So let's do this. So here gamma in, we will start from here. So gamma in into gamma in equal to, so let's take I equal to gamma in into gamma in, and we have to show that this gamma in into gamma in equal to beta in into gamma in plus in. That we have to show. So from here gamma in, so 0 to infinity e to the power minus x and x to the power n minus 1, sorry gamma in, so x to the power n minus 1 dx into gamma in 0 to infinity e to the power minus y to the power n minus 1 d. And you can write these two as 0 to infinity e to the power minus x plus y into x to the power n minus 1 y to the power n minus 1 dx dy. Now this is a double integral, and we need to solve this integral. So to solve this integral, we need some kind of transformation, and a transformation will be, say, x, okay, x plus y is there. Actually, what is our target? Our target is one beta function and one gamma function. So gamma function means e to the power one single variable, so one single transform variable. Rather we can say, so x equal to, if you put u into 1 minus v and y equal to ub. Why is that? Because if you add x and y, so x plus y will be your u. So single variable. One purpose is satisfied. Another one is that whenever you put x and y here, then you will see all these forms. So u and 1 minus v and v all is in the beta first form, beta for 1. So for that reason, this transformation is actually preferable. Now, so here we will transform the integration. The transform integration will, so let's we will just keep the limits, because we will have to calculate the transform limit. So here e to the power, what about x plus y? Here x plus y will be u. So e to the power minus u, and x is u power m minus 1, 1 minus p power m minus 1, u power n minus 1, and p power n minus 1. And now we need to change dx dy into du dv. So we have to calculate the Jacobian, and this is actually a standard idea in double integration. So j equal to del, say, xy del ub, and this is some kind of del x del u del x del v del y del u del y del v. And this is basically partial integration. What about del x del u? Del x del u means we are partially differentiate x with respect to u. That means here only u is constant, and sorry, only u is variable. So here del x del u will be your 1 minus v, and so this is 1 minus v. Del x del v will be minus u, and del y del, okay, this is v and this is u, and ultimately you will get u. So this is u into du dv. This is the integration. Now the limit. Here you can see the x has the limit 0 to infinity, y has the limit 0 to infinity. Now let me take another color. See, here 0 less than x less than infinite. That means 0 less than u into 1 minus v less than infinite. What does this mean? That means 0 less than u less than infinite and 0 less than 1 minus v less than infinite. This is the first one. And what about v? For v, we will just calculate here due to space shortage. So 0 less than y less than infinite. That means 0 less than uv less than 1, sorry, less than infinite. That means 0 less than u less than infinite, 0 less than v less than infinite. Now the range of u is 0 to infinity. Here u equal to 0 to infinity. And the range of v, so v here, as you can see, what about that range? From here you can get 1 minus v is greater than 0. So v is less than 1. So v is less than 1, and from here v is also greater than 0. So v equal to 0 to 1. Now, as you can see, we are just trying to separate those limits. So 0 to infinite, e to the power minus u, and the limit of u will be this, okay, u to the power m plus n minus 1 u into 0 to 1. This is the limit of v. So v to the power n minus 1, 1 minus v power m minus 1 dv. And this part, okay, let me just clear the board a little bit. Yeah. So the first part is this part is equal to gamma m plus n, and the second part is the beta type one. So beta m. Okay. One more thing is that you can write beta mn equal to beta nn. This you can write, you can just easily prove that one. This is very easy proof, and so this is the proof. So I am going with this. I hope I have almost cleared all the doubts. So thank you.